Thank you very much for joining us today for this October webinar of the HbbTV webinar series. We have a great lineup of speakers and a great topic today, and this is reflected by the great interest that we have for this webinar. 178 people have registered today. That is quite a lot, and I hope that most of you have the chance to follow our session live today. If not, as usual, there is a YouTube recording coming up soon after the broadcast, and there's also the option to download the PDF presentation if you like to go through it again at a later stage. You'll be informed about these opportunities by email as usual. Now, the topic today is application discovery over broadband ADB phase 2. You might have heard about this specification. It's still very new and there are exciting things you can do with it. And the experts to tell us all about this will be Joe Winograd, co-founder and chief technology officer from Verance Corporation in the US, and Klaus Merkel, senior engineer at German Broadcast Technology Institute, RRT in Munich. Now, we'll also have additional speakers this time to give you insights in the local markets and use case examples. This will be Jason Patton, Senior Vice President, Sales and Marketing of Verance Corporation, Frank Visser, Program Manager Innovation at Media Perspectives, Erik Vold, Engineer at NRK and also Head of NorDig, and Matt Poole, PMO of the HbbTV Steering Group, Chair of the DBB Targeted Advertising Working Group. And before we get started, I'll quickly give you the disclaimer. As usual, the views presented by the speakers and their companies do not necessarily reflect the views of the HbbTV Association. Let me use this opportunity to show you the agenda. Klaus Merkel is going to start with an introduction and the motivation to create ADB2. Joe is then going into the details of the solution and technical aspects. And then there's the opportunity of questions. This is very important for all of you. You've seen that in the past webinars, there are lots of questions coming up right at the end. So if you have something in your mind that you'd like to ask the speakers, please do type it in the button. There's a part of the bar that you can see with all the control navigation functions, a chat function, a questions function. You can type in your questions there and they will be sent straight to the presenters. After Joe's presentation, there is going to be a question part straight away. If you have anything on your mind that you want to ask Joe directly. There's another Q&A part coming up later for all the other speakers. Then we have the industry perspectives. Jason's going to talk about the US, Klaus about Germany, Erik about Norway, Frank about the Netherlands, and Matt is going to tell about the activities of DBB and HbbTV regarding targeted advertising. And then I told you there's the Q&A bit at the end. That is towards any of the speakers. You can say whom you'd like a response to give you or just target it at anyone, and we'll then decide, or the speakers decide. I will read out these questions because they're most relevant for the whole speaker lineup. And so please do make sure to submit those questions while the presentations are running, while the speakers are speaking. There is no need to wait until I've opened up the question section because nothing will get lost. Just type in your questions and we'll make sure if they're relevant to a general audience, we'll present them. Thank you again, and the exciting part is going to start now. I'm going to move over to Klaus in Munich, and he's going to start the presentation. Thank you very much. We'll see you again later.
Yeah, thank you very much, Jörn, for your introduction. So the topic for today is application discovery over broadband phase 2. And my starting part is to give a short introduction about this topic and tell you what the motivation really is to go for ADB, specifically for ADB2. So here you see a very simple diagram which shows the regular usage of HbbTV. So there is a broadcast stream being transmitted to an HbbTV TV set. And as a part of that broadcast stream, we have an AIT, the application information table, which is contained in the broadcast and which tells the connected smart TV, that there is an HbbTV application associated with an individual DVB channel, and what the corresponding URLs of the application are. So this is the main part, the main data part of the DVB broadcast to inform about HbbTV and to get the correct HbbTV applications launched at the respective channels. So each channel has its own AIT in the broadcast. And this is, as I said, the regular usage of HbbTV. This is how HbbTV is working today, really in the mass market. And now we go for the complications, which trigger finally ADB. So one typical complication is that the AIT is suppressed in a cable or IPTV head end. So the cable operator just doesn't retransmit the AIT, either he just blocks it explicitly, or he does a re-encoding, remultiplexing, and so on, creating the video audio encoding complete newly and just forgetting about an AIT. And in this case, of course, as you can see here, the HbbTV application can't start as the critical information bit is missing. Another scenario is here on the right-hand side, which is that there is a set-top box which ignores HbbTV, so it doesn't support HbbTV, a set-top box connected to the TV set. So the smart TV itself doesn't receive any broadcast signal. It just gets video and audio via HDMI. And again, the AIT is missing, of course, because it can't be transmitted in the over HDMI. So it's missing as well. And as well as in the first case, HbbTV is not started. But there is a very fundamental difference, which is important to understand, which is that in the first case, the AIT being suppressed in the cable head end, the TV still does the channel selection. So the TV knows the current channel and it's just the AIT missing. Whereas in the second case, the TV doesn't know anything about the channel. So it can't even identify the channel and the AIT is missing. And those are the two fundamental use cases for ADB phase 1 and for ADB 2. ADB 1 has been addressed earlier, and I'm going to show you later on the corresponding ETSI specifications, whereas ADB 2 has been addressed later. It's the more complex one because the TV doesn't know anything. And this is then what we have addressed using watermarking in ADB 2. Now, looking a bit closer to it, whereas the AIT is really the very critical part for launching HbbTV at all and is covering the huge majority of all the use cases today, the broadcast has more roles than only transporting the AIT, but it also transmits stream events. It can transmit a timeline. We have stream events from the very first version of HbbTV. We have a timeline added in HbbTV 2. The stream events are designed to deliver relatively good real-time behavior messages from the broadcaster to the application via the broadcast path. And for example, broadcasters in Germany are using this to have a teletext service based on HbbTV. And in HbbTV2, we have also then a timeline which can be used to really synchronize application content to broadcast content in a much more precise way. And also these components will be missing in both of the use cases of ADB for ADB 1 and 2. So in both cases I have shown to you, we have a loss of that broadcast components, and consequently we have a loss of functionality, which can either be compensated only very hard for the stream events or basically not at all for the timeline. But still, of course, the AIT remains the point of main concern, as without an AIT, the HbbTV application won't start at all. And you can see which workarounds we have found and addressed in the different phases of ADB 1 and 2. So we can convey an AIT in phase 1 and also 2 for the different use cases. And for phase 2, we can even compensate for the loss of stream events and timelines. So these are the two ETSI versions of that ADB specification HbbTV has published. The first already a couple of years ago, so 4 years ago already, we published the ADB phase 1. And this specification is now obsolete because the new ETSI version, so you see it's basically the same ETSI number, but a different version number. The new version, which has been published in May this year, covers both an updated version of ADB phase 1 and also then ADB phase 2, which is our main topic for today. So the old one is obsolete and the new one covers everything we have done in the area of ADB. And the details of this will now be explained in more detail by Joe.
Hello, everyone. Pleasure to join you. Joe Winograd from Verance in San Diego. I will share a little bit about how the ADB phases operate. I'll begin by discussing ADB phase 1 approach and the technical mechanisms employed. A diagram is shown at the bottom of the presentation of the broadcast path and the elements passed through the broadcast path as introduced by Klaus. To the far left, we have these elements of information that are composed into the broadcast, these 5 elements including the video components, audio components, time code components, event components, and the AIT itself. And under a normal broadcast scenario, all of these are multiplexed together, may go from an originating broadcaster through the DVB transport stream to a local broadcaster shown in the center of the screen, and then delivered from that local broadcaster or operator to the HbbTV terminal in the consumer's home, shown at the right side of the screen. And what we see as we track across the top of this diagram is a illustration of the problem that Klaus motivated, which is at some conditions at the local broadcaster, these time code, event, and AIT elements of the multiplex are lost at the local broadcaster and not transmitted to the terminal at the right. And the ADB phase 1 solution illustrated here is shown to operate over the distribution paths that are broadcast. These are the DVB transport stream paths from the local broadcaster that enter the HbbTV television either via the IPTV interconnect or a DVB RF interconnect, shown at the bottom here. And the mechanism used in a terminal for ADB phase 1 is to examine the DVB triplet. These are the 3 basic pieces of information conveyed in the DVB transport metadata that identify the service, the broadcaster and service uniquely. And the solution in ADB1, phase 1 rather, is to take this triplet and to use it in to populate a standardized host name. That is the host name of a IP address that is entered into the DNS system. So a DNS host name is formed using this triplet, and a top-level domain that is designated and managed by HbbTV through a third-party registrar known as Radio DNS. So that triplet is placed into a host name, and using standard DNS lookup, the terminal will convert that triplet into an IP address, form a standard using a standardized URL template, an AIT URL, and do an HTTP query against that URL. And that standardized URL through the DNS lookup and registrar will point to a broadband AIT server shown on the left here at the originating broadcaster. And that broadband AIT server hosts the AIT, which would otherwise be transmitted in the broadcast stream in an XML format. There's a DVB format for conveyance of a AIT in over broadband, and the server provides that AIT back to the terminal. So that's step 2 here. The AIT itself contains a list of application URLs. The terminal will select an application URL using the same procedure it would use if it had received that AIT over broadcast, reference that application URL to speak with a broadband application server, again shown at the originating broadcaster on the left, returning an application to the terminal on the right. And as identified in Klaus's chart originally, we see that this phase 1 process, based off of the DVB triplet discovered in the broadcast, will recover an AIT, allowing the application to run, but does not recover stream events or time code from that original broadcast. So an AIT can run, but the AIT may not be able to receive push notifications from the broadcaster using the event message passing capability of HbbTV, and may not be able to precisely synchronize elements from broadband with elements through the broadcast due to the lack of a time code. Also, I'll note the third element that ADB phase 1 does not cover, which is enabled by phase 2, is the ability to perform this capability through a HDMI connection, that is via a set-top box. So this is the phase 1 architecture. I'll now advance to a diagram of phase 2. Here we are. So this is a similar diagram of phase 2, which has, as I mentioned, the ability now for the terminal to receive and recover applications from a signal received over HDMI, shown through this additional line. Again, in the scenario where any of these different interfaces is lacking the timecode, events, and AIT due to processing at the local broadcaster of the DVB multiplex, we now have the ability to recover the application, timecode, and events in the terminal. And the new feature in ADB2, which enables this to happen, is the inclusion at the broadcaster here on the left side of a watermark embedder. The watermark embedder is a technology for inserting data into the audio and video streams of the original transmission. And for ADB phase 2, HbbTV chose to adopt and reference a openly specified watermark technology that has been developed in ATSC for the United States and is being deployed in the US as part of the North American and also in South Korea, the Next Generation TV, as it's known in the US, or ATSC 3 is the name of the standard. And this watermark technology includes both a component for embedding information into the audio component of a broadcast, as well as the video component of the broadcast. ADB phase 2 has chosen, as part of its architecture, to require the use of watermarking, audio watermarking for application discovery, and to leave video watermarking technology usage as an optional capability for additional functionality. The audio and video watermarks are complementary technologies. They have overlapping functionality, but also some important differences, which I'll highlight in a moment. But the watermark embedder embeds this application discovery information into the video and audio components. Now, the video carrying the watermark, the audio carrying the watermark, timecode, events, and AIT are multiplexed together into the transport stream. And if these additional metadata elements are lost, the watermark or watermarks provide the capability for the terminal to now recover information necessary to retrieve an AIT in the same mechanism that's used in ADB phase 1 through basically the formation of a templated URL that resolves through DNS to the IP address of the AIT server. And in this case, for ADB phase 2, the AIT that's returned is actually an XML-based AIT that includes additional extensions of metadata that may include time code. And also the watermark may additionally include actually conveyed directly within the embedded data, stream event, or push notifications that of moments in time in the broadcast where stream events are available on a broadcaster server. Another element of the ADB Phase 2 capability, which is new in this version of the specification, is the ability to retrieve a timeline for the broadcast stream and resynchronize different stream components. So that can be through the use of the HbbTV media synchronizer, the determination by the application of the precise media time, the current playback position, and content, even when that content has undergone substantial time shift, latency, for example, through DVR or through delay due to the broadcast distribution path. The application is able to retrieve that timeline and synchronize its both on-screen graphical overlay components, as well as, if supported through the media synchronizer, the ability to synchronize media and audio components as well to that transmission. I'll advance the slide here, thank you. The chart shown in this slide basically summarizes the differences between ADB Phase 1 and ADB Phase 2. First, looking at this initial section of the diagram under TV interface support, we see that under the two significant use cases we've discussed, which is either a DVB transmission where the signaling information is lost, either Phase 1, Phase 2 using audio watermarking alone, or Phase 2 using both video and audio watermarks will enable application discovery. However, if the interface to the television is a set-top box or some other transmission medium that's not a DVB format, an example of this might be screencasting from a mobile device over the home network to a television set. In these cases, only the Phase 2 of ADB will support application discovery through the use of the watermarks. We see then for the different features a summary here showing that application discovery is a feature that's supported by each of these different approaches, whereas for timeline, Phase 2 and with either the audio watermark or the audio and video watermark together is necessary. And we highlight here that the support for timeline and stream events in the audio watermark only case is slightly different and not as complete as the timeline and stream event support when video watermarks are employed. Importantly, the timeline with the audio watermark it is recoverable. However, if there's a disturbance in the timeline of the transmission, for example, through the viewer doing skip ahead or skip back or some other queuing or timeline modification event on a set-top box, the audio watermark will take about 2 seconds in order to recover that timeline, whereas the video watermark, when present, can enable the recovery of that timeline instantly. So we note the timeline support is somewhat less in the audio watermark only case. And similarly for stream events in the audio watermark alone case, the audio watermark carriage of stream events is not a full stream event data payload, but rather just a push notification, a message to the television that some new timeline-based event has occurred and the application is required to retrieve the data payload of the stream event associated with that time of the broadcast separately via broadband. Whereas if video watermarks are employed, a stream event can be placed directly into the video watermark and transmitted through the watermark path directly to the TV, allowing these data payloads in a stream event to be delivered with, again, reduced latency because a round trip over broadband is not also required. So that ends my technical presentation portion of this. We'll pause, I believe, for a moment to take questions from the audience on this before we will continue with the next portion of our presentation.
Yes, thank you very much, Joe and Klaus, for these deep insights into the ADB2 specification and use scenarios. As you can see, it's quite an important add-on to solve several problems that have arisen and challenges in the industry. And so, as you can see, it's market-driven, not something artificial. It's actually there to assist the market players with issues they've been faced with during real HbbTV implementation scenarios. We're happy to take your questions now. If you have anything on your mind that you'd like to ask Joe directly, now is the time to submit the question using the chat function that you can see in the bar, probably at the lower entry of the panel that you can see in the right-hand corner of your screen, where all the control and navigation features are highlighted. And so if there's anything on your mind you'd like to ask Joe straight away after this presentation, now is the time. Otherwise, we'll just continue and have a general Q&A after the presentations are finished. Joe, can you see anything? There's a question, I think.
Has not appeared on my screen yet.
Okay, it's on my screen. All right, let's do it this way. I'll read it out to you. There we go. Can you describe a use case for timeline events for broadcasters and or consumers?
Sure. So the timeline is used to allow the application to know what moment in time in a broadcast is on the screen. So let's just take maybe a basic scenario where a broadcaster wishes to have their application enable the function of identifying the actors who are present on the screen in a program through some application feature. In order to be able to support such a capability, the application needs to have a database or script that says from moment 2 minutes into a program to moment 2 minutes and 30 seconds into the program, this is a list of actors that are on the screen in the scene. And in order to be able to present that appropriately, the application would need to know at what moment in the timeline of the program is the viewer currently watching. In some cases, particularly over an HDMI input, if the viewer has a DVR capability in their set-top box, the timeline of the original broadcast may be quite different from the current wall clock time at which the application is running, right? The viewer may be watching the program with some time shift or even from a recording that's an hour or a day previous. So it's important for the application, which may otherwise only know the current time of day, to be able to determine what was the original time of broadcast of the content that's being viewed. A timeline is a DVB capability that allows a broadcaster to establish a stable and consistent mapping between the audio and video content they're transmitting and some fixed frame of reference, a time-based numbering system. And without the availability of this timeline, the application would never know the original time of broadcast of the content being presented on the screen.
Thanks, Joe. We have plenty of questions coming in now, so let's see if we can go through all of them now. Thank you for the questions. And one is regarding the market. What CE manufacturers support this today, this feature?
Yes, so I think there's going to be discussion of this perhaps in the next section. I'll leave that for Jason to answer in a moment.
Okay, and how many devices do you estimate in Europe or other markets that can support the use case for deploying HbbTV solutions over non-compliant operator set-top boxes, but going into the same direction?
Yeah, so the technology can be implemented just as a firmware component, an element of the operating system or HbbTV terminal application. So it can actually be deployed into any smart television set including if a manufacturer chose to, a set that's already deployed in the market as a system update.
Yes, we'll go into that later when the market reports come up. And but just from general view, it's a very new addition. Let's put it this way. And of course, manufacturer support probably still needs to be generated. But this will probably happen as more and more manufacturers see the benefits that come out of that. For all the players involved, but we'll discuss that later on. The last question that has come up, in terms of WM technology, HbbTV defined a specific commercial technology for it, or broadcasters or TV manufacturers can decide to choose by a specific contractual basis?
So the watermark technology that was is referenced by HbbTV standard is actually an open standard watermark. So similar to the manner in which DVB has identified codecs for audio and video compression that have been openly specified and for which there's a diversity of implementations potentially available on the market, the watermark technologies have the same characteristic. The recipes, if you will, for embedding and detecting the watermark have been openly published or available for freely for download by any broadcast equipment manufacturer or television manufacturer or independent vendor to be able to have an open, vibrant, and competitive market for these technologies.
All right, the last question going back to ADB1. What exactly has to be inserted into the distribution chain so that the triplet translates into an AIT URL?
Yeah, in ADB phase 1, there's actually nothing that needs to be embedded at all. The DVB transport stream will always contain a DVB triplet to identify the service. It's used in station tuning and building station guides. So there's nothing required for ADB phase 1. For ADB phase 2, the watermark that is used to discover and launch applications is automatically generated. It does require, again, as with ADB phase 1, a registration with an entity selected by HbbTV called radio DNS for the DNS lookup, and that's similar, comparable to registering a website URL and or domain name. And otherwise, the watermark is automatically generated with by the watermark embedder in accordance with the relevant specifications.
Just one last question that you, I believe, can answer very quickly. Is the audio watermarking for ADB2 compatible with audio watermarking for audience measurement?
Yes, there's been a fair amount of testing done with the commercial vendors for audience measurement, and the two watermarks are capable of, the various watermarks, let's say, are capable of being used together. Typically in deployments, the recommendation is to embed the ADB specified watermark upstream from the audience measurement watermark, and that guarantees that the audience measurement watermark on which a substantial business dependence relies is guaranteed to be unaffected by the ADB phase 2 watermark. But testing's been done with the watermark supplied in all the various sequences, and there's been no interactions or effect of the two identified.
Okay, and the very last one relating to the HbbTV op app, can ADB 1 or 2 be used in relation with the op app?
Certainly, there's no bar to doing so. I'm not sure that the use cases really have much overlap between the two. Typically, op app relies pretty tightly on the delivery of AITs from the operator to the television set. So I'm not sure we've identified sort of gaps in the operator application use cases, but certainly the two could be used together if a use case was identified.
So in principle, there's nothing that stands against it. Thank you very much, Joe, for these response to the questions. Quite a lot coming up. Very active audience here. Very good. Thank you very much. We'll have a second Q&A coming up after the industry perspective section, which is going to start right now with Jason from Verance, giving us an insight into the US market. Jason, welcome.
Sure. Just to discuss the United States market, the United States market has been up with this technology for the past few years. We have sort of a head start on what is now happening excitingly with HbbTV. All of the major broadcasters in the United States have deployed the audio watermarking technology. You see companies like ABC, NBC, Fox across the United States. And one of the things we saw was all those broadcasters wanted to put the audio watermark into their television signals first. This sort of gave an indication to the TV manufacturers that this was a technology that broadcasters were embracing, excited about, and ready to use. So it is deployed in a variety of different broadcast stations throughout the country. And we've been excited to see that because it's really led to TV manufacturer work on detection, which was one of the questions that came up. Verance is working with different companies and different TV manufacturers to enable the handshake between broadcasters doing the watermark on their television signal and TV manufacturers detecting it to make everything work in tandem. We've had 5 successful lab integrations across TV manufacturers and chip makers. Right now, we're doing field integrations in the United States. There have been 3 successful field integrations, and then all the different standards organizations led by ATSC are really helping push the technology with both broadcasters and television manufacturers to do the detection. One question that came up with Joe was how are TV manufacturers doing at detection with HbbTV throughout Europe and other countries. And so far, we have seen the early stages of progress. There's been discussions regarding doing integrations. Today, the television manufacturers throughout Europe do not detect ADB2. But my expectation is that for 2021 TV models, because a lot of them use the same platforms that are already being used in the US where this detection is happening, we'll transition to Europe. And so over the next 12 months or so, you should see HbbTV television start to detect the watermark. And that's it for me.
Thank you. And now it's back to Klaus from Munich, Germany.
Yes, thank you. So my first slide is a little bit about ADB1 still. So ADB1, so in general, all the ADB work has been started a good number of years ago, also triggered by behavior of cable operators in Germany, which refused to retransmit the AITs for AID and ZDF. So this has been one of our main trigger to start the ADB work at all in HbbTV. Meanwhile, the AIT retransmission happens in Germany, so this very specific problems with the cable operator is solved now due to corresponding contracts. So ADB1 is obsolete in this market segment, so the big cable networks. But ADB1 has become of interest in the context of OTT platforms. So also in the OTT context, we have no AITs specified to be transmitted in a broadcast or IPTV channels. So there are many proprietary OTT platforms which are not designed to transmit an AIT. And also in this case, ADB1 can help. We have done a proof of concept in cooperation with Tara Systems and Satu, so an Android TV Satu app, which shows ADB1 in the context of an OTT network. So you can contact me after the webinar if you are interested in this and want to have more information. And the activities here are ongoing, so something not to lose out of our site here. But of course, our main topic for today is ADB2. And I want to show here on the left-hand side the relative market share of distribution paths for broadcast broadcast and OTT for linear television in general. So in Germany, you see 2 very big portions of the cake occupied by DVB-C, so by cable here, and also by satellite. So they are sharing in a very similar. They have a very similar share in the broadcast or linear TV distribution domain. DVB-T is much smaller, and IPTV is actually growing, and this includes also OTT. If we look now at the market shares, which we are detecting, so broadcasters are detecting on their application servers, if they look where are their broadcast HbbTV applications started, then you see that satellite dominates much more than cable. So still today, IPTV and OTT is missing at all. DVB-T has just a fair market share, but there is a very significant distortion in HbbTV usage between cable and satellite compared to the actual broadcast reach. And the reason why cable is significantly underrepresented in the HbbTV reach is that although the AIT is retransmitted by now, still there are very many set-top boxes of cable operators not supporting HbbTV. So this is still the big reason why our reach in cable is by far not what it could be. And operators, as far as we know, operators do not really plan to change this, so do not really plan to implement HbbTV on their boxes. So we are still up with this problem. We have a technical reach of roughly 15 million connected HbbTV devices in Germany today. So this is the actual reach. And looking at the diagram, you can conclude that roughly some 5 more million HbbTV devices could be active if we could bridge that gap. And this is exactly the potential for ADB2. So using watermarking to pass the channel information across the cable operators boxes via HDMI into the smart TV, and there then use the identification provided by the watermark to retrieve an XML IIT for a web server, and then again start the HbbTV applications as they can be started in broadcast where it reaches directly the TV set. So our basic perspective to HDB2 from the broadcast perspective, and this is true for all broadcasters, so the public broadcasters as well as commercial broadcasters, the perspective is rather simple. So it's just increasing reach. So ADB2 as such doesn't add any really new feature. So HbbTV applications can't do more, but it's really increasing the reach they are working on those devices then. And therefore all the major broadcasters in Germany, so both public broadcasters and commercial broadcasters are currently planning to do an ADB2 showcase, to do proof of concept. And we are much interested, of course, in having here cooperation with manufacturers. And we are also very much interested and very much open to discuss with broadcasters from other countries to align the use of ADB in detail or maybe also in timing. So in Germany, we are interested in this, and we are very much interested in cooperating with others, with manufacturers, with other broadcasters in order to do it really in a good and proper way. Thank you. And I'm moving on to Erik.
This is a very interesting way, this is Jörn, the moderator, just quickly highlighting, this is a very interesting way of illustrating how broadcasters can solve the problem of non-compliant HbbTV boxes to get around that and still present the services onto many more screens. Now let's see what the situation is like in the Netherlands. Frank.
I think we are with Erik first.
Yes, Erik first.
Oh, I'm sorry, Erik. Yes, please do go ahead.
So yeah, okay. So yeah, I'm representing NRK, the Norwegian public and non-commercial broadcaster in Norway, and I'm also representing as a chairman of the NorDig API group, implementing HbbTV in the receiver specification in the Nordic region, and this is also used in Ireland. These are the numbers. I don't know if I can check. Can you click on the next one, Klaus? I don't know who has the control. Yeah, here you can see how the shares are divided in the different regions or different countries, I would say, within the region. This gives a good number, I think, of what can be approximately reached also on HbbTV, but not for Norway though. Because the other countries here, they have a majority of IDTVs being reached directly, and most new IDTVs at least have smart TV features. So the challenge in Norway is that it's the other way around. It's almost 80 or even 90%, I believe, that are going through set-top boxes. So we're not able to utilize the HbbTV capacity in smart TV. So that's a bit sad for us in Norway, and me representing NRK, that is one of the challenges we have. We have mandated, of course, HbbTV 2.20.2 in our recent specification. I think this is including the grace period as of 1st of July this year. And we're also looking into HbbTV 2.0.3 actually. That will probably be talk more about later. I just want to say that this is important though. I mean, the reach, as Klaus mentioned, is the main thing for us, because that has to do with priority and basically how much we can invest in HbbTV applications. And we're hoping for HbbTV applications to make it more interesting also for the manufacturers to enable these kind of features. ADB2 will, of course, make it possible to utilize their screens as much more than just a screen. So use the smart parts of it, I guess, and compete with the set-top boxes. Yeah. All right, we'll get back to that. Can you just go to the next slide, please? Okay, so these are the catch-up services we have. That's most of them are catch-up services, I guess. DR has been going on for the longest while. I think it's since 2010 at least. SVT is basically available through a portal, so it wasn't single until quite recently, I believe. And the Finnish broadcasters, they are already on for quite a while. Yeah, you can skip to the next slide, please. Okay, so the thing about reach, it's also quite important for us to see the value in as a broadcaster, the value in our content being discovered, right? So with the red button app, you can see basically that there is some service available just with a pop-up on the screen. So you can see it's kind of self-promoting. These are the numbers from DR, from the start of DR. And I think it's really interesting to see that you can reach these kind of numbers without really having a promotional campaign. This is really just from the value of the red button popping up. So I think it's very interesting just for that reason. Okay, please, next slide. Yeah, so there are two ways to get into your content. The red button app I spoke earlier. For us, it has just been reaching a menu. This is a trial. But another interesting way to reach content is to go to related content. So that is related to what you're actually watching right now. And we could use, as in this example, stream events for that. This is a push notification, and you actually receive a link and you come into some type of web page where you can get more updated info on just that case that you are watching news, for example. Okay, next please. And of course, another related service and a very important one for us as a broadcaster is accessibility services. This is, of course, additional audio, additional video, like sign language, and we have a couple of programs now with audio description, which is actually just a video description. You're describing what's happening in the video for visually impaired, and we also have spoken subtitles, and now we are also looking into enhanced dialogue or dialogue enhancement. And this I believe has a bit more interest in general for the public, not only for the hearing impaired, but we have actually seen that in the fair amount now that we have of reality programs, it's very difficult to hear what people are saying for everyone. So dialogue enhancement is a feature we would very much like to see. And also we have an increasing number of immigrants, not so much during the pandemic, but at least it's relevant to look into several alternative audio tracks and of course also subtitles of different types of language. Yeah, next slide please. This has been what we have been testing with the aspect watermark from Verance. We did this with Aero 100, I believe it was called. It's linear acoustic. We put it in the lab, and we simulated a broadcast on exactly the same equipment actually as we are using on air. and we were able to retrieve the watermark and see that we can make use of it. And we have also done some audio analysis to see that it was quite well, inaudible on natural content at least. So that's relevant for us before we wanted to go further on actually investing this for broadcasts. Yes. So thank you so much.
All right, thank you. And now it's time for Frank to give us an update on the Netherlands.
Yes, from the Netherlands here. In the Netherlands, we have about 8 million households, and I've drawn up a few graphs to give you some overview. We have 3 main broadcasting groups. One is the public broadcasters. The second is RTL with a number of channels. Third is Talpa, and then we have a bit smaller broadcast groups from Viacom, Disney, Discovery, and the rest. And as you can see, the public broadcasting has a market share of about 35%, RTL about 25%, and Talpa about 15%. And which button for the next slide? Yes, here it is. Besides the broadcasters, we have a number of distributors, and as you can see, there are 2 main distributors. One is KPN, which is the former Dutch state-owned telecommunications company, and the other is a fusion of Vodafone and Ziggo, which is Ziggo is part of Liberty Global. And then we have a few more smaller regional operating distributor companies. And almost all television sets in the Netherlands are connected through a set-top box, so this makes it an ideal case for the ADB2 use case that Klaus presented in the beginning. These different distributors bring different technologies with them. KPN uses DVB over IP. And Vodafone Ziggo uses DVB-C, and as you can see, there's only a very small market share for DVB-S, which was much bigger in Germany, and then there's again a smaller amount of customers for DVB-T. About some stats, I do not have recent statistics, but in about 2017 there were about 300,000 television sets polling the red button from the HbbTV signal, but I do not think that has grown very much. So what do we see as chances for the Dutch markets? There have been working group efforts. Rob Koenen, who's maybe also present in this call as a listener somewhere, and who's been working on ADB1, I think, and me together ran the HbbTV working group for the Netherlands, but it has not really taken off due to the lack of television reach, because all televisions were connected by set-top boxes. And NPO had a limited offering from with Catch-up TV. Talpa has done some tests with added in-screen visuals for the Champions League offering, and RTL Strange in the Netherlands has done nothing with HbbTV until now, but has always been involved in the working group. Now, there are of course many use cases about accessibility services, maybe only data gathering, maybe a full integrated broadcast and OTT branding offering. But what we now see in the Netherlands that again gave new interest to ADB2 is that targeted advertising is introduced both by KPN and Ziggo over their respective networks, and ad replacement is done in their set-top box ecosystem, which is at least for the Ziggo case fully operational, I think, or will be soon, using the Sky methodology from the UK. And now there is of course a reshuffling in the commercial agreements between broadcasters and distributors going on. Who gets what margin? Whose customer is it? Is it GDPR proof, who needs to give consent, is this the RTL viewer that needs to give consent, is it the KPN customer that needs to give consent, etc., etc. So for the Netherlands, ADB2 would mean a way of reaching out to the TV viewer by the broadcasters directly. And this could be for accessibility services, but could also be for targeted advertising services or just for data gathering services that needs to be researched. But at least for now, there's interest of the three main broadcasters that with the three of them have a market share of 75% of the Dutch television viewers. Advertising agencies are also interested in facilitating companies. So that's where we stand and would like to participate in the further development of ADB2. Thank you very much.
Thank you for this update. And now it's over to you, Matt, on targeted advertising.
Good afternoon, everybody. Yes, as you've just heard, I'm going to be talking about what DVB and HbbTV are doing in the space of targeted advertising. So I'll begin by giving you a little bit of background on targeted advertising in case you haven't come across it yet. The focus of DVB's effort in this space is substitution of broadcast delivered advertising with targeted advert delivered over IP. The focus of that is using existing technologies like SCTI 104 and 35 to deliver events to receivers that are capable of receiving those, or DSMCC HbbTV events for the horizontal market, and standardized ad server technologies such as FAST. But obviously, as you've heard this afternoon, in order to reach as many receivers as possible, other techniques might be needed, and of course this is directly commercially impacting in the case of targeted advertising because it's the number of eyeballs that are going to see an advert. So for markets where that's less possible, this is a very interesting subject. As of today, we've delivered 2 blue books and are on the standard vertical market with SCTI 35s and horizontal market with DSMCC signaling. And those have been published as blue books and are soon to be standardized in ETSI. Watch this space. We're presently working on something called SOME, or SOME, which stands for Signaling on the Media Essence, which is essentially watermarking. It's called Signaling on the Media Essence because it allows for other techniques other than watermarking, but presently 100% of the effort has been on watermarking, and DVB, like HbbTV, have also referenced the same open standard delivered by ATSC as Joe described earlier, which makes the HbbTV ADB2 specification and DVB's follow-up specification on SOME compatible for delivering targeted advertising. And indeed, this was the intention, although we are open to other contributions on other techniques, but they don't presently exist. So a little bit about what is happening. So the watermarks in general, the signals within targeted advertising are doing 2 things. They are launching an application. In the case of targeted advertising, this is called a DAS app, which is a dynamic ad substitution application. They are notifying the application that a advert placement opportunity is upcoming, and they are signaling to the app that to insert an advert now. So each one of these things is entirely possible with ADB2. As you've heard earlier, audio in Joe's presentation, audio watermarking is required. Video watermarking is optional, but there are certain limitations with audio watermarking. So for the first 2 scenarios I described to you, launching an application and signaling an upcoming advert, it's entirely possible to do those with audio watermarking. However, if you're wanting to indicate to do an advert, launch an advert now, which may be carrying more metadata, more payload, and being time sensitive, then it's really necessary to use video watermarking. So whilst it's optional in most use cases, in the DVB-TA use case, it's necessary for certain functions within the specification that's upcoming. When we launched the work with the DVB, of course, we immediately opened up our liaison with HbbTV, which we had already been having with HbbTV because the HbbTV TA specification has been delivered in collaboration with DVB already. So we knew that the majority of the requirements for SOME were already met by DVB TA, and we knew that a large amount of what we needed to deliver the SOME watermarking solution would already be also delivered by HbbTV. So, and through liaison, we have established that is exactly the case. There are 6 partially met requirements, mostly in around performance capabilities and audio configuration, nothing significant and per se. And the requirements group and specification group within HbbTV are looking at that, and they have agreed to start. They haven't yet started, but it's expected that both the HbbTV work and the DVB work would finish by the end of this calendar year in terms of specification work. Which means that we'd expect a blue book from DVB and something available from HbbTV early in 2021.
Right.
And that's really the end of what I have to say.
Thank you very much, Matt, on this TA update from DVB and HbbTV perspective. Now it's time for a quick Q&A. As you can see, we've run out of time, but we've decided to add another couple of minutes to respond to your feedback. There's lots of feedback, and Thomas, in the background, if you can turn me into the moderator, I'll very quickly share my screen because I've noted the main and most relevant questions. And I'm going to read out the first of them to you already, so we can start straight away. There's my screen to be shared. What should a broadcaster do to start embedding the watermark?
Yeah, that's something that Verance can help with. We have the ability to work, as Erik was mentioning, with the linear acoustic aero unit to install that at a broadcast facility today. If you contact myself at support@verance.com, I'm happy to help work through that. In addition to working with linear acoustic, we can work with other encoding vendors to allow broadcasters to start embedding today. This sort of ties into something that broadcasters can also do, which Joe may be able to touch on regarding sort of support with manufacturers.
Yes, this leads me to the next question, or the last one in this lineup. On ADB2, it seems to be the solution operator-controlled markets, but is Verance the only vendor with this watermarking technology?
Yeah, so I think currently Verance is the only vendor who is commercialized the ADB2 watermark embedding and detection technology. There's certainly room in the market and information out in the market available for other entrants, but at this point, Verance is doing the heavy lifting of commercializing the technology and bootstrapping the capability.
Okay, and the next question on ADB2, can it be enabled with operator devices like set-top boxes, or is this always required to have service embedded on TV sets?
It can be put in a set-top box. However, the use cases, right, are either that the operator is unable or unwilling to carry the signaling information, the AIT, or there's an interface that isn't technically capable of doing it, like HbbTV. In an operator environment, an operator who wishes to carry this information typically is able to, and so the watermark technology is unnecessary. But if use cases were identified by operators and they wish to take advantage of the technology, it's certainly available to them to do so.
Yes, but most probably ADB1 would do it. Yeah, so the operator box, if it does a channel selection, then I would say ADB1 would be sufficient. So if the AIT should be missing for some reason in the operator network, then ADB1 could do it, most likely.
Thanks, Klaus. Another question on the US market. Where do US broadcasters see the most potential in ADB2, rather in end consumer use cases or in advertising use cases? Can you give an overview on the objectives and use cases very briefly, of course?
Sure, very briefly. In the United States, I think that they are taking a phased approach where they're excited about all the use cases that were actually covered during this call, but it is a phased approach. The interactive applications such as catch-up or other things are what they're focused on today. That's what all the field trials relate to right now, which is taking interactive applications such as catch-up or other things and making those available. But there are steps similar to what's happening with TA in Europe, in the United States, to also do this, I would say maybe 12 months in the rears in the United States. And one last thing that I was sort of mentioning related to broadcasters, we certainly ask broadcasters to look at embedding the watermark today, as well as working with their national standards organizations to build ADB2 into their profile. With that support from broadcasters and national profiles, it will certainly help as we have conversations with TV manufacturers about building in the detection now, so we can get all this off the ground right away.
Thank you on this update, and this leads to the overview of the next webinars. And as you can see, the next one's already in planning stage, early November, the release of the HBB 203 specification. This is an update to the core specification, so this should be very interesting to hear about. The date will be announced shortly. You'll all receive an invitation to join the next webinar, and the others you can see lined up here, just as exciting. As usual, if you have anything to add, any suggestions, any comments, questions to the panelists, please send them by email to webinar@hbbtv.org. This also refers if you have a suggestion to set up your own webinar co-hosted with HbbTV, please do so. Thank you once again to our speakers today, Klaus, Joe, Jason, Frank, Erik, and Matt. Thank you very much for joining us. As usual, don't click away the window. When this session has ended, there is a quick survey coming up where we ask you about how you like this webinar so we can improve things. See you next time. Have a good day and bye-bye.